All right, so this is solving linear equations. It's our Unit 5, Day 3 lesson. A couple things you need to know. Number one, what is a literal equation? A literal equation is an equation that typically only uses variables. You will see some coefficients, like for example, you have a 2, a 3, a 2. Those are coefficients, so they are numerical. But a literal equation is typically made up of only variables. So I have an A, a B, an A, a C, a B. And my goal is to solve these equations for certain variables. For example, if I have an A, a B, and a C, it is possible to rearrange this so that A is by itself, or B is by itself, or C is by itself. We reference that as solving for A, solving for B, or solving for C. It just means get that variable by itself. Now, these tend to seem difficult, but solving a literal equation is no different than solving a normal one. You have four options at all times. You can add, subtract, multiply, and divide. So all the skills we've been using, we're going to continue using here. The only thing is that it's going to look a little bit different. For example, I have our first literal equation. It says solve for y. That means rearrange this so that y is by itself. Now, on all of these problems, you're never going to get a solution that's a whole number. You're not going to get y equals 4, y equals 10. You're going to get y equals some sort of expression. All right. Sorry about that, had someone come in. So I'm trying to solve for y, meaning I need to get it by itself. So the first thing I got to do is get rid of this 2x. We know that when we want to get rid of something, when we want to move it, we either add or subtract. So in this case, I do the opposite of a positive 2x. So subtract 2x. These will cancel, and I can rewrite. On the left, I have negative y, then an equal sign. On the right, I have a 10 and a minus 2x. Now, those are not like terms. They cannot be combined in any way. Therefore, I'm just going to have to write 10 minus 2x. You could write it the other way if you really wanted to. Negative 2x plus 10 would be the other way. But they can't be combined. They're not alike, so they're just going to be right next to each other. Now, I'm almost done. I've solved for what we would say negative y. My goal is to get positive y. So we know that this is the same as negative 1y. And if I want to solve for y, I could divide everything by negative 1. The negative 1's cancel, and I get y equals. Now, for today's sake, I don't want to necessarily leave it like this. We know how to simplify dividing by negative 1. All that it does is flips the sign. So 10 becomes negative 10, and negative 2x becomes positive 2x. This would be my final answer. We do not have a whole number answer, and that's because we have too many variables in there. If you want a whole number solution, you need to have only one variable if you have just one equation. But what we've done is we've rearranged this so that we have it solved for y. And you could have done it for x as well, but we chose to solve for y. Let's do the next one and solve it for x. Step one is to identify where your variable is located. Here it is, meaning everything else needs to be moved away. Starting with this 3y. I need to move it to the other side, so I am going to subtract 3y from both sides. On the left, they cancel. Bringing down what's left, I would have a negative 1/2 x equals. On the right, I have an 8 and a negative 3y. Those are not alike, so they cannot be combined. So they will just be written right next to each other. 8 minus 3y. From here, I need to get rid of that negative 1/2. I have negative 1/2 times x. There's a couple different ways you could go about this. You could divide everything by negative 1/2. If you would like to do that and simplify it in your calculator, you can. Another way of thinking about this is by thinking about it as x divided by 2. Whenever you're cutting something in half, you're dividing by 2. And so the opposite of divide by 2, if I wanted to cancel out this fraction, is that I could also multiply both sides by negative 2. Now, in doing this, you'd have a negative 1/2 times negative 2. They would cancel each other out. And I'd have to do the same thing on the other side. Now, you can test it in your calculator. If you divide by negative 1/2 for both of these terms, you will get the same answer. And so if that makes more sense to you, I encourage you to do it that way. But I'm going to multiply by negative 2 to cancel out that fraction, giving me x equals. And on the right, I need to multiply everything by negative 2. So 8 times negative 2 is negative 16. Negative 3y times negative 2 is positive 6y. And that would be my final answer. Again, if this part did not make as much sense to you, if you'd rather just divide everything by negative a half, you can do it. Divide 8 by negative a half, divide negative 3 by negative a half, and you'll get the same answers. Dividing by a fraction is the same as multiplying by its reciprocal. So instead of dividing by 1 over 2, I multiplied by just 2. Moving on. Solve for n. Step 1, find your variable. There it is. Step 2, start moving things away from it. So subtract 6p on both sides. I got to get rid of that. Those cancel. On the left, I have a 15 and a minus 6p. Those are not alike. They cannot be combined, so they'll sit next to each other. And on the right, I have 3n. We know that if I want to get n by itself, I divide by 3. And if I do it to one thing, I got to do it to everything. You can do a giant fraction bar of dividing by 3, or you can do little ones. All we're doing is dividing everything by 3. Now simplify if we can. 15 divided by 3 is 5. Negative 6 divided by 3 is negative 2. That p stays there. And 3n divided by 3 is just n. Now I have an equation where n is written by itself. So n equals 5 minus 2p. Same thing as the original, simplified and solved for n. Next one, solve for q. Find your q. Next step, there's a couple different things we can do. I am going to distribute this a. When I do that, I have a times q, which will just be aq, minus 8 times a, which is 8a. That's going to equal 23. So I'm going to start by distributing that a. My next step is, remember what variable I'm solving for q. So everything that does not have a q needs to move across the equal sign. So this negative 8a is going to need to be moved across. I will do the opposite of what I see. Add 8a to both sides. On the left, these have to cancel, leaving me with a times q, which if you want to use parentheses, you can. If you want to use a dot, you can. But when we multiply two variables, we sandwich them together. Equals. On the right, we have no like terms. So they will just be written one after the other. Next step. If I had a number like 2q equals something, and I asked you what would we do from here, the answer would be we'd have to separate the 2 from the q, and we do that by division. We know the rule is divide by whatever is in front of the variable you're looking for. In this case, it looks different, but it is no different. I'm solving for q. I have an a in front. I don't know what a is, but it doesn't matter. I know that if I divide this by a, since these are being multiplied, these a's have to cancel each other out, because a divided by a cancels. We say it equals 1. If I divide the left side by a, I need to divide the right side by a. And for today's sake, we can just write a giant divide by a, and we can get our solution. The solution being q equals 23 plus 8a divided by a. And we can keep it here. There would be our solution. I've rearranged it so that q is by itself. Distribute, move, divide. The same steps we would do with normal algebra problems. This time there's just more letters involved. The good thing about these literal problems is that you can typically do these without a calculator. There's not a lot of numbers involved. It's more or less testing your algebraic skills. Solve for w. This one we're going to do a little bit quicker. Here's my w. Everything needs to be moved. So minus z, minus z. On the right, these cancel. On the left, I have u minus z. Those cannot be combined. So they'll be written one after the other. Now that I have my variable kind of isolated, there's just one term left, I got to separate this w. It's v times w, so I'll divide by w. Do it on both sides. Those cancel. And I have u minus z over w. There is no way to simplify that any further. That's two things being subtracted and divided by w. v is by itself. So that is my final answer. I have taken what I started with and I rearranged it so that v is by itself. We say we solved for v. Next one, solve for k. Here's the k, it's up top. All of that's being divided by 5, so my first step is going to be do the opposite of divide by 5. That would be multiply by 5. These 5s will cancel, leaving me with k minus 2. And on the right side, I have 11j times 5. We'll just multiply our coefficients together. 11 times 5 is 55, so that's 55j. Now to get k by itself, we need to add 2. The 2's cancel out, leaving me with just k. And on the right side, we have 55j plus 2. Those are not alike. They do not have the same variable, so they can't be combined. They must just sit next to each other. Just like that. Next one, solve for b. This time, b is on top, and I have a binomial on the bottom. Two terms, a d minus 4. My goal is to get rid of it. Well, we know from the last problem that whenever you have a fraction, let's say x over 3, if I want to get rid of this divide by 3, I do the opposite. I multiply by whatever is on bottom of that fraction. These would have to cancel. In this case, we have something along the lines of x over, let's do a plus 2. If I want to cancel out this fraction, I need to multiply by whatever's on bottom. This time it's 2 numbers on bottom, so I'm going to put some parentheses. I'm going to multiply by a plus 2. Now, on top of the fraction, I'd have an a plus 2, and on bottom I'd have an a plus 2, and they would have to cancel. It's no different than what we've been doing. We're just adding in another term. If you have 2 things on the denominator, you multiply by both of those. So in this question, I have d minus 4. To get rid of this fraction, I would have to multiply by d minus 4 on both sides. D minus 4, D minus 4. Let's simplify the right side first. The D minus 4 cancels with the D minus 4, leaving me with just B. I'm going to write it down here. On the left side, you have G times D minus 4. Now, we could distribute that G, but there is no need to distribute if you're not looking for the variable. We've already found the variable, or I should say we've isolated it. So we don't need to continue doing work on the left side. We can write it exactly how it looks. That would be D minus 4 times G. And if you like to put the G in the very front, you can put the G in the very front. The location of it doesn't matter. You have a monomial times a binomial, which is why we need those parentheses, because that whole thing needs to be multiplied by G. Next one, solve for A. There it is. It's inside of these parentheses, so if I'm going to get it by itself, I need to distribute. Doing so, we get n equals b times negative h squared is going to be negative b h squared. Or you could write negative h squared b. Doesn't really matter. I'm just multiplying them together so they stick together. Plus b times a is ba. So multiply that out. Next thing, find the variable and move everything away from it. Here's the term that has my variable, so let's move the one that doesn't first. Move this to the other side. We have a negative bh squared, so if I want to move it all, I just do the opposite of what I see, which is addition, bh squared to both sides. When you do it on the right side, these have to cancel anytime you subtract something from itself. On the left side, you have 2 terms. Those are not alike. They don't have the same variable, so they can't be combined. So we'll write one and then the other. The order doesn't matter. I'm going to write my bh squared plus n equals ba. Because on the right side, these cancel, so they're now gone. Just left with ba. Excuse me. I'm solving for a, so when I do that, I don't even look on what's on my left side. I'm just looking at how could I separate the b. I have b times a. The opposite of multiplication is division, so I'll divide by b. Now that I've done it on this side, I have to do it on the other side, keep things nice and even. So divide that whole side by b and write the results. This will be good enough for today. bh squared plus n over b is equal to a. And that would be my solution. Last one. Originally I said solve for f. We're going to cross that out and we're going to solve for g. Let's get g by itself. Looking at this problem, Here's the g, it's on top of the fraction. First, I want to get this term to be by itself. So I'm going to move this plus 3 over to the other side. So minus 3 minus 3. On the right, these cancel. On the left, these are not alike. One has an n, one does not. That means they cannot be combined. They must just be neighbors. 3n minus 3 equals g over f. All right. To get g by itself, I got to get rid of this fraction. If I were to read this out loud, it'd be g divided by f. The opposite of division is multiplication. So I need to multiply by f for those to cancel, which means I got to multiply the whole other side by f. I'm going to need parentheses there, because not just the 3n, but also the negative 3. If I multiply one side by f, I multiply the whole other side by f. We could distribute that f, but there's no need, because g has been solved for. It is now by itself, meaning everything the way it is fine to write. F multiplied by 3n minus 3. I've rearranged it so that we solved for g. We got g by itself. Again, to reiterate, the rules of algebra haven't changed. You might see some things that you haven't had a lot of practice in, and this will be a good opportunity to practice. But your 4 options are multiply, divide, add, or subtract. It just depends on if you want to move something. So here I moved something, so use addition or subtraction. Or in the last step, if you want to separate. This g and the f are sandwiched together by division. I need to separate them with multiplication. The only difference is now instead of numbers, you're doing it with letters. So assigned on Delta Math most likely will be where your homework is today. I'll have a few problems for you to practice on your own. They're going to range in difficulty from some simpler ones to some more difficult ones. Try your best, show your work. I believe you can do it. Let me know if you guys have any questions.